Hello, I'm Professor Richard Tamboro, Daytona State School of Mathematics. I'm here to show you how to do a hypothesis test for proportions. Proportion data is any data that's a percentage or a proportion. An example is the favorability rating of Congress, or the percentage that are people that are pro-choice. If you have data that is given, best described as a percent or a proportion, then you pick the hypothesis test statistic formula for proportions. That has a p-cap and a p. A p-cap is sample proportion. P is population. The population proportion is typically given in the test to claim statement. When you get both proportions, you put them in the formula and apply the formula. So this is for proportions. So let's look at our problem. We have a claim that the proportion of households with at least one cat is greater than 0.35. So what the claim is saying is that 35% of households in the USA have at least one cat. One or more cats live there. You don't own cats, they might live with you. So that's what we're testing. Okay, so I'll make a list of my data. I'll start at the top with the hypotheses. The first one is the null hypothesis that always gets the equal sign. I don't have to worry about that one. It's unbiased. It always assumes equal. Okay, then the alternative still gets the 0.35, which is the population proportion claim. And in this case, we have greater than. So I'll add a greater than symbol to that. And notice the notation is now P for T distributions and Z distribution. Numeric data hypothesis test, you use capital M, which is mu, the Greek letter mu, for the population mean. Proportions, we switch to a P. It's the only one that uses the P, typically in elementary stats. Okay, so P is given as 0.35. The complement to that is 0.65. That's Q. Q is 1 minus P. Okay, so 0.35 added 0.65, you get 1. The sum of the probabilities is always 1, so this has to add up to 1. So that's the complement. Okay, 66 households were surveyed. 26 were found to have at least one cat at home. And we find the proportion of households sampled that have at least one cat by dividing the number that had a cat by the number of households surveyed, X over N. That is P-cap. Now, if you're doing a confidence interval, then you need Q-cap, 1 minus P-cap. We don't need Q-cap for this formula, so we're not finding it. Okay, alpha was given, the significance level is given to us as 0.10. So for that, we'll find the critical value. Now our critical value is based on a one-tail hypothesis test. You've got a 1 or 2 tail. This is a 1 tail. It's greater than, so it's a right tail. There's no degrees of freedom. This is a Z distribution formula. So you find your critical value. 1.282, it goes to the right, again because it's greater than. Okay, so that's the preamble. We're ready now to apply the formula. Okay, so I need my sample. It's a proportion. It's almost like a sample mean. It's just a different word. So it's like having a sample mean and a population mean, but it's proportions. Okay, so sample proportion, 0.394. Start this off with a parenthesis and subtract population proportion, and then we divide. Now, under the radical, I need P and Q. Make yourself a nice little list. Don't mix up your P's and Q's. You'll have an error if you do. Okay, so I'm multiplying P times Q and then divide by the number of samples. Okay, so 66 samples. Now put that in your calculator. Again, pay close attention to the syntax here. got to get your parentheses, your division symbols, all have to be in those positions when you input into your calculator. Okay, I've already calculated that. Let's see, what did I get? 0.749 standard deviations. So our unit of measure, again, with hypothesis testing, test statistic formulas, is always standard deviations. Even the critical value is 1.282 standard deviations to the right of the mean. Okay, so our test statistic is 0.749, so that's somewhere over here. It falls in the fail to reject region. The fail to reject region is between 0 and 1.282. The rejection region starts at 1.282, goes towards the right. You should never have a test statistic on the left side of the bell curve if you have a rejection region on the right. So if you get a test statistic on the left and a critical value on the right, make sure your inequality is correct. If it's a two-tail hypothesis test, then you'll have a rejection region on both sides. You won't have that concern. But when you have a right tail, make sure your TS and CV are on the right. If you have a left tail, CV and TS on the left. They're never on opposing sides, except for due to error. Okay, so we are not in the rejection region. So we fail to reject HO. The only other possibility would have been reject HO if the TS landed in the rejection region. It did not. So we did not reject the hypothesis. The null did not reject. That means we have a possibility of error type 2. All that means is we did not reject the null. If we made the wrong decision, the wrong conclusion, that would be an error type 2. Okay, reject is error type 1. Okay, so let's see. So the conclusion, this time, we did not reject this. So the data is indicating it is 0.35. It's supporting that claim, that assumption. It's not supporting the claim. So there's not sufficient evidence to support the claim of greater than 0.35. That's the meaning of our conclusion. The alternative is a proportion with one cat is greater than 0.35. We cannot support this claim, and because we are not in the rejection region. Thank you very much.